Hi friends, it's Miss Sauls here. I wanted to hop on today and do some math with you guys. So one thing that you have been working on in your packet this week is taking some equations and trying to figure out, do those equations equal each other or not? And so I wanted to show you some examples and then also give you a tool that you can use at home when you are solving those equations and those different things in your packet. So I am going to pull this up. I have some stuff here ready for us. So I wanted to start with an example like this. If you had the numbers 2, 7, and 9, and your job was to figure out a fact or a math sentence and equation for 2, 7, and 9. How could we do that? Well, one thing that we could do that you guys know really well is to use a number bond, right? That part whole. So looking at this number, we could fill out the number bond for these. Now we know part, whole. Our whole is our biggest number. So I'm going to put this number 9 right here in the whole for my number bond. And that's easy. You guys can draw a number bond. And then that leaves me with my two parts. I have a part that is 2 and a part that is 7. So part, whole, we have 2, 7, and 9. So we could come over here to these addition equations and we could plug in our parts and our whole. So the first one, remember when we're writing these into an equation, we do part plus part equals whole. So I have one part that is 2, and I have another one that is 7, so that would be my second addend, and 2 plus 7 equals 9. Now if I wanted to find another adding equation for these two numbers, I could just flip-flop them. So instead of 2 plus 7, I'm going to flip-flop my parts. 7 plus 2 equals 9. See, that's not very difficult, using that number bond to write some adding equations. So now, what if I wanted to make some subtraction equations? Remember that when we subtract, we can't start with one of our parts. A subtraction equation is a whole minus a part equals the other part. So my whole, remember, my whole down here is 9. So I'm going to start with 9, and I'm going to take away one of my parts. So maybe I'm going to take away the part of 2, which leaves me with 7. And then I can do the same thing down here. Remember, when we're subtracting, we have to start with the whole, take away a part equals a part. So again, my whole is 9. And last time I took away this 2, so this time I'm going to take away 7. So 9 take away 7, or minus 7, leaves me with 2. So that's just a quick example of how I used a number bond, part, whole in my number bond, to solve some, or to create and solve some adding and subtracting equations. So you have some problems in your packet this week that look like this, where we've given you the numbers that you're going to work with and create them. But you have some other problems this week that look kind of like this, where it says list the facts for, and then it gives you a number. So the number that I am looking at today is 11. So list the facts for 11. Well, the first thing I did was I drew a quick picture. Now I'm using the computer here, so I was able to draw these fancy stars, but you can just draw X's, circles, dots, anything that's really quick, and draw out that number. Then I want to come up with some equations. So I'm going to start with my group of 11 here, and I'm just going to circle part of this number here to just give me something to work with. So I circled, that wasn't the best circle, but I circled 1, 2, 3. So 3 And then let's see how many are outside of my circle. I've got 1, 2, 3, 4, 5, 6, 7, 8. So 3 plus 8 equals 11. Now, one thing you can do is you can go through there and just flip-flop. So instead of 3 plus 8 equals 11, you could flip-flop that to be 8 plus 3 equals 11, and that would be fine. Or you can do what we did a second ago and draw another circle. I kind of like drawing the circle, so I'm going to do that again. So I'm going to circle off these. So I have 1, 2, 3, 4, 5 stars in my circle. 5 plus 1, 2, 3, 4, 5, 6 equals 11. So nice and easy. I just went through there. I circled parts and then use those parts to create an adding sentence. Now we're going to do the same thing. If I can get this to erase here, we're going to do the same thing and create a subtracting equation. Okay, so remember, when we're subtracting, like I just said, we're going to start with our whole. Yeah, we have to start with the whole. That's a W for whole. And I'm going to take some away. So I know my whole is 11. That's the number that I have to begin with. I'm starting with 11. And a number we haven't looked at yet would be 4. So I'm going to try taking away 4 and see what happens. So I have 11 and I marked out 4. And let's count up how many are left. 1, 2, 3, 4, 5, 6, 7 are left. So 11 minus 4 equals 7. Now I could go through here and start with 11 again and then flip-flop those parts. So 11 minus 7 equals 4. Or I could do what we've been doing and try marking some out. So I'm going to try again, starting with my whole, and the whole here is 11. I'm going to try taking away 9. Let's see what happens. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I took out 9 stars, and that leaves me with 2 stars. So 11 minus 9 equals 2. So just now I came up with 4 very different equations. And like I said, you can work on finding those flip-flops or different equations. You can also work on just going back and using strategies that you know, strategies that we are comfortable with, things like counting on, counting back. You can use a number line. If you have some objects, you can build a model. There's lots of different ways to solve these, but I just wanted to give you guys some ideas of ways that you could solve these equations that are in your packet. As always, if you have any questions, please let me know. I am here and happy to help. I will see you later, friends.